So after I did the video on the IG-18 Heathkit signal generator, and I was trying to figure out a good way of doing distortion measurements on amplifiers, I figured the path I was on wasn't going to be the path I needed. So I was looking on eBay for these Panasonic machines. Now they have the VP-7721A, which is a really nice unit. It's got 2 channels, it's got the LCD display, and it does the automatic measurements, but it was very pricey. Now I decided to look back farther in time, and I looked at this VP-7721, and it looks like a really nice piece of gear for doing what I need. The problem is it's only 1 channel, so you can do one amplifier at a time. But this one here came up, and it was for parts repair. Now it has a problem. It says it powers up, but none of the front controls work, which tells me, okay. So if you look at this picture here, it's powered up. It's got 0.0.0.0 on the display. It has 2 ranges lit up here, the 1.6 to 15.99 kilohertz, and then the 0.16 to 1599 kilohertz. So those 2 ranges are displayed right here. They're lit up, which tells me this thing's locked in a state of vegetation, like the microprocessor's not working. None of these buttons are lit. All these buttons have LEDs behind them, and you'd think one of them would be lit on boot up, but none of them are. We've got a meter that's pegged right to the max. This under range light is lit up, but that's all there is, and it says it's unresponsive. The front panel controls are unresponsive. So I had to think about this. Let's look at it. Nice piece of kit, built to do the business, and it's looks like it's very easy to use. It's got some good range here from 5 Hertz all the way up to 160 kilohertz. You can test amplifiers. What else does it have? It's got weighting, buttons here for weighting, and it's got signal to noise ratio measurement, distortion, and input level, noise level. And then it has an output, oscillator output. That's the big thing that I'm missing on my current distortion meter, is I don't have a distortion oscillator built in. And then it has 2 inputs. It's got switchable grounds, so I can isolate grounds from input to output. It's got a nice input level meter, and let's see what else it has here. It has the distortion level, signal noise ratio, and distortion level. And here's your range up here on these LEDs. So depending on what range you're in depends on which LEDs lit up. And then you have your nice large meter, and you can monitor here on the scope. So it's got all the features I want, except it's not stereo. So this is coming from Korea, and I pulled the trigger on this one and I purchased it. I did not pay the full amount he's asking. I made him an offer and he accepted, which is great. Now I wasn't quite sure if I wanted this or not, because let's see here. So I wasn't quite sure if I could pull the trigger on this, but I went online and looked, and lo and behold, here's the manual for it. And it's got all the operating instructions, everything I need to run this piece of gear. It's got all the specifications. Let's look at some of the specs. Distortion measurement range, 0.003% to 100% full scale deflection, which is minus 90 dB to 0 dB in 10 ranges. So it's very capable of doing low level distortion measurements. That's the main one I'm looking at right now. It's got, like I said, it's got from 5 Hertz to 160 kilohertz in 4 ranges. So that's good. Flatness. 20 hertz to 100 kilohertz within plus minus 0.5 dB, or 5 hertz to 500 kilohertz plus minus 3 dB. So it's very capable. Signal to noise ratio 0 dB to 90 dB, 10 ranges. Yeah, it's got some good specs. Looks like it's a well built piece of kit. So I pulled the trigger on it because, you know what, all this information is very valuable, exactly how to run the thing. And then at the end it comes back with schematics. That's just the important part. So I'm going to need schematics to fix this thing. Now I have a feeling it's probably just a dead power supply, because this thing will have multiple power supplies inside. And if you have one that's dead, that's operating the microcontroller, see, here's all the schematics coming up. Let me go to the last page. Is the power supply. Let me go down. Here's the power supply section. You got 2 windings. 1, 2, 3, 4 regulated outputs of minus 15, plus 15, negative 5, plus 5. Yeah, so if one of these supplies is out of commission, that'll freeze up the entire piece and it won't work. Plus it has battery backup here. I don't know, battery backup. Has battery backup too for the memory that might be corrupt, and that might be a part of the problem as well. It looks like this little circuit here deals with the battery backup. And yeah, plus 5 volt battery. This goes to the control assembly, which is your microprocessor. So we might be missing a battery voltage or a power supply voltage. So when this thing gets in, I'm going to be doing a repair video on it, and I'll probably tack this on inside just so you guys can see my reasoning and thoughts behind this. So like I ordered it a couple days ago, it should be here by Friday, which is very good coming from South Korea. Alright, so I'll let you give you an update when it arrives. Well, look, it arrived on my doorstep. Okay, so this was amazing. This came from South Korea, and shipped by UPS. Paid dearly for that shipping. It was over $200 Canadian, which is we get ripped off regardless of what it is, because our dollar is so poor. But this took, I think I bought this on a Tuesday and it showed up on a Friday. So that's how good it was. I was impressed with the shipping. Now, if you know me, I'm not going to buy something that's 100% working. I'm going to buy something that's broken and needs repair, because I enjoy the challenge of fixing things. And yeah, why not? We have the skills, let's use them. So this thing arrived. Let's have a look at it. It looks pretty good. It's nice, not beat up. Let's zoom in here a bit. There is this thing here is damaged. This is a ground connection, and that's broken off. I can replace that. Oscillator output, power switch, or frequency amplitude display with keypad entry. These are our 3 measurements: level, signal to noise ratio, and distortion. And then we have our filters: high pass filter, 30 kilohertz, 80 kilohertz, and a weighting filter. 2 inputs. Ranging for the meter, auto ranging, measurement range. Okay, so this is input level. Okay, and then on the right hand side we have our meter that shows level, signal noise ratio, and distortion. That's our output. Here's our monitor output for a scope, and it's got like a LED scale here. It tells us what range we're in for the meter, which is kind of nice. Really well built machine. I haven't looked inside yet, but I have a feeling it's full of the Panasonic garbage caps that leak, and we're gonna have to do something about that. On the back you got IEC connector for power, serial number, remote control. You got a DC output. This is a DC level that tracks the front panel meter. So as the meter deflects, this voltage rises. That's all this is for, and this is for remote monitoring. fuse, mains input, and voltage switching. And right now it's set up for 220. So let's see. Let's have a look at this. You can see it's set up for 220. It's down and up. So this is be 220. We need 120. So this goes up and this comes down. So that should be 120 there. We need to replace the fuse. We have a 1/2 amp in here already, I'm assuming. Let's see. Oh, this is a 1 amp fuse. Okay, so we don't need to change it. We'll just go with that. Alright, let's plug it in and try it out. Do I dare do that, or should we open it up first? Is there a watt meter? I think you can read it. Let's turn it on. And we have absolutely nothing. 0. Okay. But it does work. Let's switch it back to 220. Plug this first. Switch this back to 220. Let's try this. So we're only feeding it 20 volt, 120 into 220, and we still have nothing. So obviously something's wrong here. Did we blow a fuse? No. Okay, let's pull the top off and let's set this back to 120. Pull the top off and have a look. Alright, pull the lid off. We've got some heat stains here and heat stains up here, which relate to, I'm not sure. So what's going on with this thing? I think we might have, these are the voltage select switches back here. I think it's probably maybe the switches are dirty with oxidation. Maybe they're not making connection. And this power switch, what's wrong with that? You can see a little power supply board underneath here. Somebody's, it's got a little sealed NiCad battery that is not leaking, which is a surprise. Okay, let me pull the bottom off and then get a better look at underneath. Okay, here we go with the bottom lid. Somebody's been in here. Fingerprints, a bit of dust. Let's see what we got happening here. Not much of anything, it's all encased. Let's see. There's a transformer, all the power supply is up here, but it's mounted upside down. It's this big aluminum box. It's interesting. Interesting piece of gear. Got some fuses here. They don't look blown. I think these would be, yeah, the protection fuses for the oscillator output. Okay. Wiring and meters. Don't see anything underneath. You know, everything is up top here. So I might have to remove, this is going to be kind of a pain to work on too. I'm going to have to remove some boards. This one sits in a slot. Connectors all around, so this will be easy to remove. Just have to remove the power switch, and then I can pull it out. Maybe I can get it out without removing the power switch. But I want to get to the power supply. We want to check power supplies. Okay, so let me start working on this. I should take some photos. I want to get these all mixed up. Maybe they already are mixed up, who knows. It's a bodge wire. It's interesting. I'm going to have fun exploring this thing. Just looking at this Torre transformer. I hope it's not burned out. It looks a little warm in there. Pretty sure it's the switches on the back. The voltage selection switches are just oxidized, and I'm going to get an ohmmeter out and start testing those. Stand this up, and then I'll start with that. Alright, so that switch is up position. That's good. That's open. Nothing there. This switch is in the down position. That's open. And that's open. Oh, this one might. Yeah, we got some open switches here. So I'm going to have to clean contacts and figure this out here. So let me disassemble and we'll bring it back in. Alright, here's a better look at it. Okay, so this is in the up position. So it should be connected here. And that is over here. See, this one's open. And this one is in the down position. So it should be this wire here. That's open. Wow. Pretty good switches. And this one's open. Let's see if I click this up. That's good. That's open. So we got some bad switches. I think what I'm going to do is take this plate off, and then I'm going to undo these crimps. There's crimps on both sides, and that'll remove the front plate, and then I can get inside and clean the switch properly. Pretty sure this is what the problem is. I got continuity here in all three. This side here, I do not have anything. So what I'm going to use is Electrosolve. This is zero residue, so it'll dissolve the solvents. The solvents in this will dissolve any oils and flush them out and leave no residue behind. So let's just give it a good flooding. Can wipe it with the swab too. I think I'll do that. Get a cotton swab. Clean the buttons, the contact buttons. This one's kind of arced. Use a little bit of oil inside a switch can really mess things up, especially on a power switch. Okay, I think that's good. I'll reassemble and we'll test it. I'm going to have to resolder some of these connections. Okay, I think I got this mess sorted out now. I have to redo these connections and one other connection, this connection here, this two gray wires. And I think that stray wire went here with this other one. They're both kind of the same color, even though they're... Okay, so let's check this switch out and see if it's working. Got my beeper here. So let's see what we got. Okay, we got 0 ohms there, 0 ohms there. Here we got 25 ohms. Okay, that's good. What is this? 30 ohms. It's jumping around a lot. 0 ohms there. This one should be 0 ohms, but it's not. 17 ohms. 45. 4 point something. Something is not right with this switch. Just try and operate it. We still got bad contacts on this right here. One way to check is we can measure. Actually, let's put this back in. I'm going to reinstall this and then we'll check it. We'll check the resistance of the coils when we switch through the ranges. Okay, I got it back together. I think it might be working. I don't know. Let's connect an ohm meter to the mains input, and we're going to check measurements, resistance measurements of our, turn this on. Okay, it's not. So this is at 240 volts right now. Let's switch it to 120. 13. Let's switch this to 100. 11. That's even less than 120. 120. Come, this thing won't take any measurements. What's going on? Still got a bad switch. This stupid meter, I don't know about. Let me try a different meter. Let's try this one. Doesn't want to work either. It's freaking out. $120. Yeah, that's right. 120 would be a higher ohm than 110 or 10. So that's right. Look at this. There's no measurement here. So I'm going to leave it in this and we'll power it up. It's set for 120 right now. And that should be correct. The worst that will happen is we pop a fuse, right? A 1 amp fuse. Was that 50 cents? Pretty sure it's set up for 120 right now. Alright, here's our power meter. It's at 0. Let's turn it on. Jumps up to 22 watts. And everything looks correct. Except we have nothing working. It's like the microprocessor is in a locked state, or either it's not stepping through its instructions, or we might have a missing power supply. That's what I'm guessing. What does this do? Nothing, 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 nothing. Everything's nothing. Okay, it's like it's dead. We have no function whatsoever. Alright, let's check our power supplies. Okay, this connector here came from this board and it goes directly to the power board. So it is power, it's marked power here on this. So there's 5 pins. Let's see what we got for power. Let's turn this thing on. Oh, we got a little different stuff going on here now. We got action. Look at that. We have action. So maybe we have a short on that board. Things are starting to work. Look at that. Okay, so what does this thing say? We have On this pin, 1.25 volts. That's shouldn't be that low. 3.71. Negative 6.3. 13.7. And negative 16. I don't know if any of these are correct or not. But it's interesting that I unplugged that board and things start working again. Distortion, signal to noise ratio. Okay, our meter's not pegged. This thing just came back to life. Let me plug this back in. Okay, things are working still. That was a really easy fix. I don't know what is going on with this thing, but it is working. Relays are clicking, I can hear. Making cool noises. Let's shut this off. Let's turn it back on again. Yeah, and it seems to be working. So what was the problem? We got bad solder joints. I might have to start pulling boards and inspect some of these, the backside, to see. That was really weird. My next step was a microprocessor. I was going to connect the scope and see if there's a clock signal going on here, but it doesn't. I don't think I need to now. Amplitude. Let's go. Yeah, set the amplitude. This is a nice piece of gear. Okay, let me close this up and let's play with it. Alrighty, let's try this thing out. Now it's doing that weird stuff again. No, it's still working. Still working. Okay. Let's get our oscillator output into our input. So if that's correct, this should be, okay, let's take this off. Take that off. We're doing distortion. Feeding an oscillator. Ooh, my crappy cables. Feeding it right into the input. And our level. Let's see. So is this our distortion? 0.01 scale. So we got 0.0075. Am I reading that correct? We're doing distortion. Took all the filters off. Frequency is 159 kilohertz. Four dB. Turn this down. Minus 10. I think it's working. Yeah. Awesome. So let's do a different frequency here. Let's do 100 hertz. Minus 10 amplitude. And settle down. 0.01. 0.0028. That's what that reads. Am I doing this right? Auto ranging. Measurement range. That's automatic. Okay. Input range, over, under. Yeah, that switches ranges for the input. It's all automatic. Can't really override it. 0. Look at that, it picks up the little stray from my finger. That is working good. So now that I'm quite pleased I have a working functional distortion meter, analyzer, I came out this morning, turned it on, and it was doing its weird thing again where the controls weren't working and the meters were pegged. So it does have a fault, and I will address that. And then I turn it on a second time and it's working fine. So it's very intermittent. But first let's play around with it a bit. Before I tie into it, let's try doing some distortion tests and see how well it works. Okay, I'm going to attempt to do a measurement on this crappy old realistic SA155. Now, I tried in the last video, it didn't work. So we got it set up now. I don't know what it's reading right now. It's saying 10% and it's up here, but I got the volume turned right down to 0. And I have it set for 1000 hertz tone. Oscillator output going in. Got a dummy load on the amplifier, 8 ohms. So let's turn up the volume here and see how this measures. We'll bring it up, bring the level up. Full deflection. Right now I'm measuring. You can see on the scope the distortion. Let's slow this down so it's not so. That's what the distortion looks like coming out of the amplifier. What are we at here? We're at 0.3. So we're sitting at 0.1% distortion. Now let's raise the bar a little bit. Let's turn up the power. Turn up the power some more. See, once the meter comes up to 10, it wants to switch ranges automatically. So what do we have here? So we're on the 0.1 scale, and we are still, so we're sitting at 0.06 right now. Let's see, there's let's try a low pass filter, and that takes out the AC hum, and our distortion dropped to 0.05. Let's try a 30 kilohertz filter. Let's remove a lot of the highs, and it even drops it even a little bit more. So apparently this thing's working, and our distortion on this amplifier is actually pretty low. If I keep going up, I'm getting closer and closer to clipping, I think. Yeah, we're on the 3% distortion scale, and we are at 1% distortion THD. So yeah, we're starting to clip, and you can see it on the screen how the distortion changes going into clipping. Or maybe that wasn't clipping. What is that? Let's drive this amplifier into clipping. Okay, right. So we're at 100% distortion. We're at 40% distortion. Let's take it down. it down. Jack this up a bit. Trigger is not happy here. And 20%, or no, we're at the 100% scale, and we're still at 25% distortion. Let's take it down. Let's see where the point of clipping is. 10. Turning down the volume. Right about here is where it drops to 0.1. So that would be our maximum power right there. Let me measure that. This might be good for what I'm trying to do here. So this is the left channel. Let's measure the left channel. And we have 3.44 volts RMS. An 8 ohm load. So yes, I think this is going to work very well for me. I think this is what I want. Now, shut this off, and let's. We still need to deal with this because it is misbehaving. So let's go in and do our work. All right. So my plan for this is to disassemble. I want to inspect all the printed circuit boards for cracked solders, and especially the power supply. And I want to get in and really scrutinize this power supply, make sure that there's no cracked solders, the caps are good. And there's no problems there. So I'm going to go through one board at a time. It's not going to be something worth filming unless I find something that's really egregious. Now, I was kind of sitting on the fence about capacitors on this thing. It seems to be working fine the way it is. And all of those Mashashita caps seem to be, they look like they're behaving themselves. But that can be deceiving. As soon as you start putting these old caps back in service, they can start leaking. Now, I don't see any corrosion on any of these caps at all. But that doesn't mean that won't start happening if I put this back into service. What has been going on here? Somebody butchered in. Oh my God. Look at this mess. Somebody really struggled with that chip. That is a mess. I might just go in and clean this. It's double backed with another chip. What the hell is going on here? There's two chips stacked on top of each other. And they're paralleled. Why? U29. I'm going to have to look at that. I might have to take that all apart and clean this. Somebody really... Yeah, this is what I want to inspect the boards because of this. And look at over here. I don't know what happened there, but something critical. That's a 100 ohm resistor. Yeah, a little suspicious stuff here. Well, good thing is it is working, but I have a close scrutiny of these parts. This is a TL191CN. Is that what that is? TL191CN op amp, looks like. Wow, okay. And I don't think this is factory. I think that might be something else too. That is a National Semiconductor. What is this thing? Can't read it. It's an LF357H, whatever that is. in a socket. Alright, after lots of cursing, I finally got this power supply out. I had to take out the main board above it first. And I figured I might as well go through and get my label maker out and just mark every connector, because there's so many connectors that look identical, but they're not marked in any way. So as I pulled it apart, I put on the corresponding jack number. So that keeps it simple. So I can take this right out. I can actually, I'm going to desolder the transformer wires here and remove it completely. It looks fairly clean, but I am finding some cracks on some of these transistors, the capacitors, the diodes, the bridge rectifier. I think there's some cracks. So I'm going to go through and clean this and make sure it's 100%, especially these jack connectors. This is a single-sided board, that's why it's cracking worse than the others. And then I'm going to ESR all these caps. If they pass, they're going to get left alone. So, and then also I got access here. I can replace the ground post. I can access the nut and replace that. I'll get that done too. Okay, so I went through this power supply board and I found lots of cracks. These main rectifier diodes here, these 4 connections were cracked. This one was okay. The 2 center transistors had cracked joints, and then I think that was it for cracks. And then I started pulling capacitors out and testing them. They are like, these are 470 at 16. They come back at like 350 to 330 microfarad. They're getting dried out. All of these are been replaced with solid polymer caps. Now I'm pretty confident I caught the problem of what was going on with this distortion analyzer. I think the power supply was the cause, and I think I got this problem licked. Now I removed this dead battery. This is a nickel cadmium battery, 3.6 volts. So there's 3 cells in here, right? And it's got some corrosion on this side, and it only measures 1.5 volts. I'm going to replace it with this, and I can load this up with nickel cadmiums, and I can remove them and charge them as I want. So that's taken care of. There is a resistor here in the bottom corner of the board that was blown open. I don't know if you can't see it. It's really a tiny little 1/8 watt resistor that was blown. There's a hole blown inside. It's a 10 ohm resistor, and somebody tacked that abomination on top of it, which is another 10 ohm resistor. I'm just going to remove them both and put a decent sized 10 ohm resistor. This connects the chassis ground to the electrical ground right here between these 2 traces. So maybe somebody had a ground loop or something that damaged this. So I'm just going to remove it and replace it with a resistor. And then I can put this back together and start using it. Check the main cans. They're all okay. They're not perfect, but they don't need to be replaced yet. We got a 10,000 at 16 volt and 247 at 35 volts. Okay, these are all good. And everything else is good. So I'm going to put it back together. Clean the back. I can see why somebody chose to kludge in the chip instead of removing the board and doing it properly. This thing's a real bear to work on. You have to disconnect a lot of wires and move things out of the way, and it's almost a nightmare to work on. But this thing had spillage all over it of something. I think it was just rosin flux. I'm not sure. There's this resistor here. This is another 10 ohm. I think this is one of these grounding resistors. And somebody blew open the one on the power supply, and somebody blew this one open, probably from placing a hot voltage on the ground. Just trying to clean up some of this soot and carbon. Now, I want to deal with this mess in the center here, this thing. Now I'm going to separate these boards. These two boards are joined together by connectors in the middle. This board, don't need to do anything to it. I just want to get it out of the way so I can get to this one. I think I'm going to install some sockets here and just clean this up. It looks horrible. Let me try a little bit of this around here. Something catastrophic happened. I don't know if it was just the way they soldered this together or... Clean out underneath the belly. Yeah, that is really strange. I don't know why somebody would piggyback a chip like that. Unless the chip in the bottom underneath is totally gone. I don't see how that would work. Okay, I'll separate these boards, desolder this, and I'll put some socket in here. This is an 8-pin socket, or sorry, 16-pin socket. So I desolder this chip and take it off, and look what's underneath. Another chip of the same part number. So what do we got here? Is somebody patching, like, is half of this chip dead and somebody patched in another chip to take over, or what are they doing here? You don't just stack op amps, do you? No, you don't do that. What are they after? That is so weird. And look at the back side. It's been nobody's been back here desoldering, but it's been destroyed from heat. You can see those 4 pads in the middle are just, oh, I feel sorry for them. So I'm gonna get that other chip off and get those pins pulled out, and then I'll get a socket installed. See those little wires they were using to tack everything together, and pulled those off. So, wow. I'll keep plugging away. I think I'm just about there. I don't know if I can do this on camera. Let's try this. I'm just going to pry up on the chip, the screwdriver, while I heat some of these pins. Seems like they're letting go. They had a big fire here. It's all burnt. Okay, let's see if I can get those holes cleaned out. Alright, got the pins out, got the holes cleaned. I had cleaned the surface too. It doesn't look that good, but it's quite a scorch there. But we're going to use these. I'm going to drop these in. And these are going to be my new 16-pin dip socket. And that's soldered up. Now I did pull traces off here. I'll show you. These two pads came up. They were connected together. But if I look on the back, these two are connected together at the back. So we should be okay to just drop these in, solder it, and it should all work. And there's other pads missing here too. There's a pad missing here and here. And as far as I can tell, there's nothing connected to them. This one are live. These ones have nothing connected to them except for this one. So I'm pretty safe. I think I got it all. So drop these in and solder this down. Starting to get played out and frustrated from this. So let me see if I can flip this over. Yeah, it's gonna want to fall out. Let me bend a couple pins here. Just going to bend this pin here a little bit. Nope, won't let me. There's some tape, hold it down. Just until I get it tacked in. Tuck the corners in and then I'll do the rest. Okay. Looking good. Looking better. Okay. Looking a lot better. There's one there I couldn't solder because there's no pad on the top or the bottom. I don't think it makes any connection, to tell you the truth. All right. Now, why do I got two? I'm going to clean the pins up on these and we'll see which one works, which one doesn't work. I have a feeling these are metal oxide semiconductor switches, single pole double throw, I think. I'm not sure, but they're electronic switch, and I think there is two of them in here and two of them in here. So clean these pins up and we'll get one of these stuck down, see if the device works or not. Well, there it is. Its chip is in. It looks a little better than it did before. So I'm just going to go through and check continuity for all these pins to make sure that I do have a connection to the outside world. Some of those pins, some of those pads were looking pretty bad shape. So make sure this is working. I don't even know if this chip works or not. And where's my other spare chip? It's kicking around here somewhere. There was two of them. Yeah, I don't know. So I'm not even confident this thing's going to work now that I replaced that. But I'm just going to make sure I got, like I said, continuity. This is actually a switch. The TL191 is a switch, a BIMOS switch that is controlled, and it's like a little relay, electronic relay. That's what it is, really. And it's on the input. Here, I'll show you on the schematic. Okay, I'm not exactly sure what this circuit does, but I have a feeling it has something to do with the input level measuring and meter driver. So what we have here is an input level. It comes in, this is half of the U29. This is a TL191, and it says half here because it comes in two halves. Now I can't find the other half on the schematic. I have a feeling this schematic is either incomplete or portions of it aren't scanned, or I don't know. I don't think it's all here, but I do see it here, and we can see it's an input level. There's a 35.7K 1% resistor going in, and this is where all the carnage happened. So I have a feeling that whatever voltage somebody jammed in this was excessive enough to blow up this chip. And from what I think, this just keeps going through the signal and goes out to the meters on the right hand side here. So this is doing probably range and measurements up here. I think this is ranges. I'm not sure because we have these switches here, these 6 switches, and then it switches through the ranges. So I have a feeling that's what this is. Something to do with the input metering. That chip, as far as I can tell, they're only using half of it. So I don't know, because I see 1, 3, 4, and then it jumps to 11, 12, 13, 14, 15, 16. So there's a whole portion of this chip they're not using. I'll have to check it, confirm it on the board if it is being used. And if it is, I don't know where it's happening, because I can see other chips down here. If I look at this, go down. Here's 2 more of those TL191s. Here's half of one here, half of one here, half of one here, and I'm assuming this is the other half. And let's see here. 1, 3, 4. Yeah, okay. Pin 2 is not used. Okay. So yeah, I have to go through and confirm the inputs and outputs. We have 4 pins for each half of the chip. 1, 3, 4, and 16, or 6, 9, 5, and 8. It looks like I'll have to confirm those, see if it's working. See, here we have portion of the switch that's not even being used. I'm not sure how these switches operate. If it's like a toggle switch, let me look. Okay, here's a data sheet for this chip. Now it's kind of confusing because it covers the TL82, 182, 185, 188, and the 191. So they're just configured different, I think. The TL 182, 85, 88, and 191 are monolithic high-speed analog switches using BIMOS technology. They comprise of JFET input buffers, level translators, and output JFET switches. The TL blah blah blah, or the TL 182 is single pole single throw. The TL 185 is single pole double throw. The TL 188 is a pair of complementary single pole single throw switches, as is each half of the TL 191. So the 191 is just a double up of the 188, and it's got 2 single pole single throw switches in it. So we can go down and look at this. Here's the pinout of the 191 right here. We can go through and check all that. Pin 2 is not connected, that's right. And pin 7 is not connected. Okay, I'm going to have to check this. Okay, I see what they're doing here. So input is low on A, switch 1 is off, switch 2 is on. Input A is high, switch 1 is on, switch 2 is off. So they work opposite each other, and they're independent of each other. Okay, and there's no connection between the two. Makes sense. Kind of like this. So what does this do then? It's just a switch that switches between this line and this line and feeds the signal through. So this is our input level, and then this, when it switches to this other one, this is a level adjust. And let's go look at what this is down here. If I look down here, this little circuit here is the knob on the upper right corner of the analyzer. It's got a pull switch. Where's this pull switch right here? It's variable, absolute. And what that does is it switches this relay, which clicks this relay, and it switches in either, let's see what it's doing here. Normally open, normally closed. Normally closed goes through a 2.21K resistor. This doesn't make sense. Okay, you've got 15 volts coming down through a 15K resistor, goes through to this contact, and then goes back up and out. And then if I click this, this switches, and we have a variable. Okay, we have a variable potentiometer here. So if we click this switch, we can adjust this this reference voltage that's been fed through. If we don't, it's going to be fixed by this 2.21K resistor. That's what I'm seeing here, and that's on this up here. So it's either fixed or variable depending on how this switches. I don't know what this switch does. It picks and chooses between the two inputs. Not sure why. It's a little bit complicated, the circuit, so I haven't taken the time to figure it all out. Okay, we're not out of the woods yet because I put this all back together, been doing some testing, and we still have problems. It still locks up. See, right now it is working. Okay, but then after a while it freezes. I can select different functions and play with it a bit. This meter is dead now. I don't know what I did there. It hasn't worked since I put it back together. I have a feeling this meter is directly involved with that TL191 switch IC that I pulled out and did the work on. You can see right here it's just at 0. There's no signal getting through to this meter. Okay, this one here seems to be working, but it's measuring such a high rate of distortion. It's measuring, what is it measuring? Almost 30%, 40% distortion, 25, and then it does a twitch thing. You can see that. But what's most disturbing is it'll lock up. It'll lock up and none of the controls in the front will work. And then we have a situation where, let me try this again, let's shut it off. Turn it on. And you can see when I first turn it on, I get the 0, 0, 0, 0, and then it switches in like it wakes up. Now there's something going on back here with a connection or something that I'm not entirely sure about. See, now I can't get it to lock up. Okay, I just had this thing on for a while. It's been on for about half an hour, and I've been playing with it, and it was working. And you were able to switch between different measurements, but now it's locked up. It's locked up in level, and it's not responding to any controls. So something's wrong with the processor, or something's going on that keeps it from working. Controls don't work. We're stuck on a display of, I think it's frequency. I think this is frequency. But let's address the elephant in the room. Now, I had a lot of think about this, and the more I think about it, the more I have to do it and stop avoiding it. I think these caps need to go. Now, I measured some of these caps when I pulled them out of the power supply, and they were down in value as much as maybe 25%. And I'm measuring, spot checking a few of these caps here today, and they are down in value. So I think part of the problem with this thing is its caps. Even though they're not leaking yet, which really surprises me, because these caps are notorious for leaking. And you pretty much guarantee to find a leaking cap with this age and these brand of caps. So I think I'm going to bite the bullet and start replacing caps. But we need to figure out why this thing is locking up, and I still think it has a problem with power supply, to tell you the truth. And I don't know if the cap thing is related. I kind of highly doubt it, but you never know. You replace some of these caps, They're mostly in the power supply circuits, and they're doing bypass filtering. But you start replacing caps, you might find some open ones, some dead ones, and that might just bring this thing back to life, but I kind of highly doubt it. I think we still have a serious problem somewhere in the power supply, or maybe in the microprocessor itself is locking up for whatever reason. So I think I'm just going to go ahead and start doing the recap. There's really not that many. This controller board doesn't have very many. There's a few back here, a couple there, a few inside the can, and that's it. This is our input board. This does our A and B channel, and there's some switching here with some relays and some attenuation, and then it gets into this circuit here, which looks like it's amplifier, I'm not sure. And there's caps in here. These are all power supply caps, and I'm measuring them, they're down. So this little module here is the input, and then the analyzer section here has a few caps as well. And there's a power supply connection. I can check power supplies now, but we're going to do that as well. Let me flip it over. And here's the other side of the analyzer board, and this is all loaded with caps as well. Most of them are power supply and you know, bypass. The oscillator circuit itself is full of caps as well. So this is our oscillator circuit. It's all shielded in a box. And then our power supply, which we already looked at. It's getting quite warm. So maybe it is a problem here. I'm going to start poking around. I'm going to first look at this power supply and see if we can figure out what's going on with it. And then we're going to start doing some of these boards. I'm going to remove these boards. There's two boards here together. There's the board under here is the CPU board, and then the oscillator. So I'll attack these one at a time, and we'll get through it. I should get my heat camera out and see if there's anything that's cooking here, like a shorted chip, which might be loading down the power supply. That's a possibility too. Here's a typical example of what I'm pulling out for capacitors. This is a 220 at 16 volts. If you can read that. If I hold it still, maybe 220 at 16 volts. It should have an ESR about 300 milliohms, and the ESR is 10 times what it should be, and the value is down around 120 microfarad. It should be at 220, so it's down 100 microfarads. So this is pretty typical of what I'm seeing in this analyzer. So I'm going to pull them all out and go through. So I'm pulling out all the caps and going through it. I'm going to replace every one of them. I already finished the input board for the analyzer. I'm going to use solid polymer caps for any power supply, and for anything else it's just going to get regular electrolytics. Now, I don't anticipate any other problems on this. It all looks good. I gave it a good clean, and we should be back in business. Now, these relays are probably going to be my next focus, so we'll just have to see how these go. I can test a lot of these right now since the board's out, and I think I might just do that. Alright, so I just finished recapping this thing, and it was actually way better than I expected. It's not bad. For the most part, I use solid polymer caps wherever possible, because these are all power supply filtering. And very few spots the cap was in the signal path, so like here and here, here, there's a couple, but the rest of them are all power supply bypass. So yeah, they got all polymers, and it was a good thing I replaced these caps too, because even though none of them were leaking, they had some of them were very low in value and ESR. Some had failed. See, here's more on this board. This is all the analyzer assembly. Now, last time I assembled this and put it together, it wouldn't work, and I found the reason why. One of these wires broke off the board, this brown one, and this brown wire here supplies power to the front end board. This is the front end board. It sits on here on these standoffs, and then these cables go through the hole Actually, it goes like this. And that brown wire supplies power to this board, and this board wasn't getting power, so that's why it wasn't working properly. So here's a good look at this one. This is the input board. Input A and B here and here, and they have these 2.2 microfarad caps, DC blockers at the inputs to protect the circuitry from any DC. So that's all ready to go back together. Here's the microcontroller CPU board. Here's a couple little caps here I replaced, and this one, that's all there was there. And this is the oscillator assembly. Okay, it's all got, and it's got some bodges in the back. And I actually removed the resistor and replaced it with chip resistor just to clean it up. So this can all go back together now, and I have a good feeling that it's going to work this time. Let me get busy. I'll start. I gotta clean some stuff here. This is the oscillator assembly box. It's not fully shielded. It's got transparent ends, and but I'll get it all back together, and then I'll bring you back in. All right, we are back together, hopefully for the last time. Now let's do our first power up. And if we get a bang, you know we have a cap in backwards, so let's try this. Yeah, it's locked up. So we need to do some more to figure out why this thing's locking up. Okay, after some probing and prodding and sticking my fingers where they shouldn't be, and figuring out, you know, this thing's really complicated with its wiring harnesses, and if you leave something unplugged, yeah, of course it's not going to work. And if you eventually find it and figure out how it's going to go, but it is working now, so I have control over the frequency. Let's go to amplitude. I have control over the amplitude. It's going down, back up. Let's check it on the scope. So I've got full control over the oscillator. Why is this thing twitchy? It's twitching. Let's modify the amplitude, going down. Okay. Let's go and modify the frequency range. There we go. And then we can modify the frequency. So that's all working. Working good. Okay, we'll feed the signal back in. And it measures 0.0026, but we have no shields in place, so I put my hand near here and we're picking up all kinds of garbage from signal to noise ratio, level, amplitude, turn it up. Seems like everything's working now, and that's a blessing. So this is going to be fun to use. I'm going to close this thing up, put the covers on, put the shields in, and then we'll give it a test. Alright, I think it's time to do a test. So let's try it out on this unrestored Citation 19. It's been sitting here collecting dust, waiting for its turn. Let's turn this thing on. And we're doing distortion. So let's turn on the amp. See, I don't know if that's proper though. That should be twitching like that. Yeah, I don't think that's right. Might still have a problem. Wow. You can hear that thing power up. So we've got a dead transistor here. Okay, enough of this. Let's go distortion. Let's set this for 1000 hertz. Okay, it already is. Amplitude. What is going on here? We have a reading here. Let's turn on my other meter. Okay, we're getting a little something out of the... Let's turn this thing up. So we're at point 0.1516. Let's keep going. Okay, coming up in power. Getting lower distortion as we go higher in power. So we are at 0.0. What are we at here? 1.0065, which ain't bad. We're not quite at clipping yet. 5 volts AC in the output. Is that right? Let's keep going. Oh yeah, okay. What are we at here? 0.005 still. And what is our maximum? Let's turn it down one. Okay, there's our clipping. .6. I don't know if you can see this. So we're actually putting out 141 watts right now, and we're doing it at 0.03% distortion, just before clipping. If I turn it one more, we're up at 10% distortion. Okay, so turn this down. Turn it down one more. Let's see here. I can... Yeah, it wants to do this. Okay, do that. There's my resolution. That's what I wanted. Okay, keep going up until we hit clipping, which is right there. Clipping's right here. 33.43 volts RMS. $139.6 watts. This amplifier's not doing too bad for being an old bag of crap. Now let's check the other channel. Yeah, it's getting toasty. Let's turn this down. I wish there was a button to press and it would shut off the output instead of having to turn it down. Let me shut this off and I'll switch it around for the other channel. Okay, I'm back. Let's turn this on. And signal's connected. Let's start measuring. Turn it there. %, distortion. It's very low signal going in, so it's probably just measuring noise. That's what I'm guessing. Okay, let's ramp this thing up. Actually, before I do that, let's check out these filters. High pass filter. Okay, so that takes out quite a bit of noise. So maybe we're just picking up hum. We're at 3%, kick in the 400 Hertz high pass filter, and it drops down to 0.7%. But you got to remember we're at a very low level here. So let's just keep going up. 55. I have it on the scope too. Okay, my cables are not. Maybe this just needs a clean. It's a dicky connection here. I'm just going to squeeze in the fingers. Just so they put a little more pressure on. Still. Okay. Keep going. See, that's a poor ground. I'm getting, there we go. .01% distortion. We are not even at 4 volts RMS yet. And this says 10. Yeah, we're at 4 volts. So this meter does work pretty good too. Let's turn this thing up. .01% distortion on the other channel, the left channel, and we're not quite there yet. .30 volt range, I'm at 22.5 volts. Yep, 22.5 volts, exactly what my HP says. So that's actually pretty accurate. Let's go up. Okay, now we're getting to clipping. The last 2 clicks, and the distortion jumped up. So, right about here, I would say. It says we're at 34, and my meter You did invest in some good cables. These are brand new too, and they're definitely gonna have to do something with this connector. If it's the connector, or let me try a different cable. Here's a look at the distortion signature, and if I go up a little bit, you start to see spikes, and that's clipping. And if I keep going, it just gets more severe. And then, yeah, we're into like 30% distortion here. Turn it down. We're at about 1.5% distortion. Keep going down. See those spikes are going down, and then the background comes up. There. Now that's more accurate of what the amplifier is doing, not the clipping. So we're sitting at 0.03. No, we're sitting at 0.015. So this left channel is a little noisier than the other one. A little bit higher distortion on the left channel. So I think this is going to fit my my needs very well. I have to fix a few things up. This is garbage. No, I don't know. I think it's probably, maybe, I might have to change this, replace it. It's seen a lot of use, and it's probably dirty. But then it feels like I don't have a ground here, proper ground either. I might have to connect the ground up to the amplifier. Let me try that. Yes, that's the answer. I connected the ground wire, and this noise is gone. Well, for the most part. Oh, I had it connected. Okay, there we go. Yeah, now it's working. Still has a dicky connection though. Just for curiosity, let's try this at let's try it at 20 kilohertz. So kilohertz. Okay, let's start. A lot more distortion at 20 kilohertz. We're sitting at 0.0224. Let's go up. Alright, we're getting close. We're sitting at 0.06 or 0.058 and climbing here. Okay. %5 distortion, turning it down. Sitting at 0.6%. Right about here. 32.8 volts RMS output. Yes, works very well. Well, there you have it. Pleased with the outcome of this one. I had kind of a little bit of stress over if it was going to be a basket case or not. I paid a lot of money for it, so it would have been a big loss. But it's working good, I think. I'm still not sure about this business here. It's in manual range right now. If I turn it into auto, it starts hunting. Maybe it's not going to do it now. Yeah, it probably is going to start. But this is what went into it for caps. Oops. And a dead NiCad battery for battery backup. Replace the replace the ground post, which is going to be useful. Now all these caps are the notorious bedwetters. Now these, I didn't find one of these leaking, which is probably a good thing, because if this was leaking, this board would have been a hell to fix, and it would have been a lot more involved to do board repair because of corrosion damage, rather than just popping in a new cap. But these caps, I did find a couple in here that have failed, believe it or not, and for the most part they're all power supply caps, except for maybe 5 or 10% of them. Now the power supply caps, I replaced them all with solid polymers, very low ESR. This should have zero problems with power supply in the future. A lot of these had high ESR. Some were at 10 times the normal it should have, and yeah, so this was definitely required to get this back going again. Now I'm still not convinced that I made a repair on it. It hasn't locked up on me since I put it back together and got the wiring harness figured out, because when I first clicked it on, it was locking up, and I had some troubles with some of the connectors. They were hidden and I didn't see them, and of course they didn't get plugged in, so you got to be careful with that. But this is a good addition to the bench. I think you're probably going to see more of it. I want to do some before and after evaluations, you know, before I do a restoration, a full recap or whatever, replacing transistors. I can do before and after, and we can watch the difference between the two, and I think it should help in the long run for putting out good sounding pieces of equipment. You know, like I said, it was a bit expensive, but thanks to you guys, because you guys helped with this. You made donations to the channel, and with your clicks and views, I do get a small amount of money, and that all went towards this, buying this for the bench. So look forward to seeing some more of it in the future, and hopefully you can work it into the videos more. Alright, thanks for watching, take care, and we'll see you on the next one.